Problem 3, very nasty integration problem because this can be done by hand. So f of x is equal to x squared, which means the derivative is 2x. We take a look at the radius of that spinning object, and we see, since it's going around the y-axis, r of x is simply x, just like if this were a shell method. So surface area is equal to 2 pi, integral from 0 to 2 of x times the square root of 1 plus 2x quantity squared. And we have 2 pi, integral from 0 to 2 of x, changing that square root into a half power, so make it easier. Have the quantity 1 plus 4x squared being raised to the half power. This is a u substitution, where u is equal to 1 plus 4x squared. Du is 8x dx. So we need an 8 in that problem, so we're going to put it in there. So you have 1 plus 4x squared being raised to the half power times 8x dx, but that 2 pi used to just be by itself. Now we're dividing by 8. That simplifies to pi over 4, and we perform our u substitution, where 1 plus x squared turns into u, so that's u to the half, and your 8x dx turns into du. Using the power rule, we add 1 to a half to get 3 halves, so you have pi over 4 times u to the 3 halves divided by that same 3 halves. Flip-flopping that upside down, we get 2 pi over 12 times the quantity replacing u with what it is, 1 plus 4x squared. That's being raised to 3 halves power and being evaluated from 0 to 2. 2 pi over 12 turns into pi over 6, so we have pi over 6 times the quantity of 1 plus 4x squared being raised to 3 halves power, again being evaluated from 0 to 2. So we have pi over 6, sticking a 2 in there, we get the 17 to the 3 halves power minus 1 raised to the 3 halves power, which is kind of nice because that's just going to be 1. And just changing things back to a radical, we have pi over 6 times the quantity of the square root of 17 being cubed, 3 halves turning into that square root of 17 to the third, and then minus 1, just combining everything together to get a final answer of pi times the square root of 17 being cubed minus pi, all divided by 6.